Okay, so before we do any other stuff, let's just kind of again go ahead and put our Math 150 hat on, our college algebra thing. And, you know, not only do we look at some basic, try to spell this out, not only do we, when we have y equals f of x, right, there's a lot of things we look at in that function, right, where, you know, again, it's extrema, it's domain, it's range, right? It's high point, where it's increasing, or it's decreasing. So there's a lot of things we analyze. But one of the things we also did is we transformed these graphs. I think the most famous one is when we had something like y equals x squared, and we took that basic function, right? And then we basically took it and we shifted it over to the right, or we shifted it up, all right? Or we reflected it through the x-axis. We stretched it out, right? Made it nice and skinny. So that's basically what we're going to do. Now that we have a basic cosine graph, right, which we now know pretty much looks like that, right? And now that we have a sine graph that in all practicality looks like this over the same period, we're going to do the same thing. We're going to shift it right, we're going to shift it left, we're going to shift it up, we're going to shift it down. We're going to be doing all kinds of things with it, and then creating basically new functions by translating a given function. And I like to call them basic functions. So we take a basic shape and we basically transform it and create another shape, right? So hopefully that was a memory jog. We did that a lot with x squared, and that's pretty much what we're going to see in 4.1 and 4.2 pretty much continuously. Okay, so there's a really quick memory jog. Let's get to it. Let's start manipulating our cosine and sine graphs. Oh, and by the way, again, what we want to do, I don't know how your instructor taught it back here, but usually what I try to do with my kids is we usually try to take at least 3 data points. And if I can transform those 3 data points, I transform basically the whole graph, because it's kind of like the DNA, right? These are like the core 3 points in a I think it was 0, 0, 1, 1, and negative 1, 1 on an x squared graph. If I knew how these 3 points were manipulated in any translation, the whole rest of the graph would have to follow. So the same thing here, right? We got to know where we have the 0, 1 as our first data point. We have pi over 2, 0 as an intercept. We have pi and negative 1 as a low point. I think this was 3 pi over 2, 0, and then we were at 2 pi and 1. So if I know how to manipulate those 5 points, everything else will follow. What you'll also kind of get is, notice that I'm breaking the x-axis up, right, into quarters. Quad 1, quad 2, quad 3, quad 4, if you're thinking of the circle. And the same thing here, right? We have 0, 0. We had pi over 2, comma 1. We had pi and 0. This point right here was 3 pi over 2 and negative 1. And then we were back at 2 pi and 0. So for a sine graph, those are the major points that we're going to be doing. And again, you see that I'm basically breaking the x-axis up: action in quad 1, action in quad 2, action in quad 3, and action in quad 4. So the rest of the graph has to follow those big 5. So we're going to constantly be manipulating it. Hopefully, if you don't already have these major things memorized, whether it was through the unit circle or using rectangles or whatever the case might be, you need to definitely get them committed to memory now, because this is what's going to really help you out, as you will see real shortly. Okay, so there you have it. Let's start getting down to business.